Good morning all of you. I am Tanushri Dadai from Civil Engineering branch, and today I am going to teach you your Theory 1 paper which name is Structural Mechanics. So in the last class we discussed about the numericals based on principal plane, principal stress and principal strain. And today we will discuss some another problem regarding on principal stress and strain system. Okay. So see, here is a problem which is a point in a crank shaft. The stresses on the two mutually perpendicular planes are 30 MPa and 15 MPa. Here you can see that 30 and 15 are in positive because it is tensile in nature. Then the shear stress across these planes is 10 MPa. That means here tau is given. Okay. Find the normal and shear stresses on the plane making an angle 30 degree with the plane of the first stress. Okay. That means here your theta is directly given. The angle in between oblique plane and the first stress, that is the vertical line or vertical axis, means y axis, the angle is 30 degree. Then find also magnitude and direction of the resultant stress on the plane. So here you have to determine four things. One is normal stress, second one is shear stress, third one is resultant stress, and fourth one is the obliquity angle, that is the angle of the resultant stress with respect to the principal plane. So first of all we have to write what are the data given. So you can see, always take the first value of the question as sigma x. That means the stresses along the x-axis. Okay. And the second value of the stress is taken as the sigma y. That means the stresses along the y-axis. So both are in positive due to the tensile in nature. So sigma x equal to 30 MPa, or you can say Newton per mm square, and sigma y equal to 15 MPa, or you can say it is 15 Newton per mm square. Then the shear stress is given as 10 MPa, and next one is your theta value is 30 degree. Okay. So find out the normal stress. So we know that the normal stress or sigma n is calculated as sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 cos 2 theta plus tau xy sin 2 theta. So your sigma x value is 30 MPa, sigma y value is 15 MPa. So 30 plus 15 divided by 2 plus 30 minus 15 divided by 2 cos 2 theta, that is cos 2 into theta value is 30 degree, plus tau xy. So value of tau xy equal to 10 MPa. So 10 sin 2 theta. So sin 2 into 30 degree. So by calculating all the calculation, we got the value 34.91 megapascal. Okay. So now comes to the shear stress. That means the tau value. So we know the formula for the tau, which is sigma x minus sigma y divided by 2 sin 2 theta minus tau xy cos 2 theta. So your sigma x is 30, sigma y is 15, theta value is 30, and tau xy is your 10. So just put the values here, which is 30 minus 15 divided by 2 sine 2 into 30 minus 10 into cos 2 into 30. So by calculating all these things, we will get the value 1.5 megapascal. Now comes to the resultant stress. So your resultant stress denoted as sigma r, which equal to the root over of normal stress square plus tangential stress square. So we got the normal stress as 34.91 plus your tau value is, or tangential stress, or you can say shear stress value is 1.5. So by calculating this value, we will get the resultant stress as 34.94 megapascal. Okay. So now comes to the angle of the obliquity, which is the angle between oblique plane and the resultant stress. Okay. So the formula is tan phi equal to tau by sigma n. So phi is the symbolical representation of obliquity angle. So if tan phi equal to tau by sigma n, then phi will be tan inverse tau by sigma n. So by putting the value, which is tan inverse tau, which is your shear stress value, which we got 1.5, and divided by sigma n, which is 34.91. Hence, we will get the value of phi, or angle of obliquity, as 2.46 degree. Okay. So in this way, we got all the values. Now we have to draw the diagram with the normal stresses and shear stresses value, along with resultant stress and the value of phi. So here you can see, according to the question, the sigma x value is 30 MPa, which you can see, and the sigma y value is 15 MPa. After that, the tan or tau xy is represented here as 10 MPa, which is already given in your question. So now you have to draw the value of normal stress, tangential stress, resultant stress, and angle of obliquity. So you can see this direction, this is the direction of the normal stress, which we got as 34.91, and shear stress or tangential stress, you can see here this arrow mark is represented as 1.5 MPa, and the angle of obliquity, which is this angle. Okay, this angle is denoted as phi, which equal to 2.46 degree. Okay, so you have to draw the diagram after the completion of the calculation part. Now another problem is there, which is the principal tensile stresses at a point across two perpendicular planes are 100 MPa and 50 MPa. Find the normal and tangential stresses and the resultant stress and its obliquity on a plane at 20 degree with the major principal plane. Okay, so this is another problem based on the principal stress or complex stress system. So we discuss this question in the next class. So today this much. Thank you.